Hey everyone, Mr. Ray here with our next lesson in grade 10 Applied Math. We're going to continue with our linear equations unit, and we're going to continue on with where we left off on the lesson 1, which was solving 1 and 2 step linear equations. So hopefully that helped you solve some of the simpler linear equations where there's one or two steps to solve any of those equations. But you're going to see some more complicated looking equations that are definitely more than 2 steps, possibly 6 steps. So today we're going to it's basically part 2 of solving linear equations. We're going to look at the more complicated type, and I'm going to give you a process step-by-step guide for solving equations that will work with any type of equation, any linear equation. So hopefully that's something that you find of value. So just a reminder of some of the important definitions. We're working with equations, so remember equations have a left side, an equal sign, and a right side. You've got a variable, normally it's x, which you may see once or more than once in the equation. Okay, and what we do with equations is we solve them. And what does it mean to solve an equation? It means we want to find the value of the variable, usually x, that makes the equation true. So when we solve an equation, we end up with some statement. Well, it's an equation, x equals a number. And that tells you that if you plugged in that number for x in the equation and simplified both sides, you would get the same number on both sides. And usually there's only one correct answer, one value of x that makes it true. Occasionally you might see an equation where there is no solution, and sometimes you might see equations where there's infinite solutions. We're going to be focusing on the more common one where you only have one equation. Okay, the way we're going to do that is basically comparing an equation to a scale. Talk about that in a second. And what we're going to do, once we're thinking about that scale analogy, we're going to be undoing operations that are in the equation so that we eventually get x by itself. So we're going to be using opposite or inverse operations. So if we see that x is being multiplied by 2 in the equation, the way we'd undo that, the opposite of multiplying by 2, is dividing by 2. And when we apply the opposite operation, we end up with the number we started with. For example, if I added 2 to a number and then subtracted 2, well, those are inverse operations, and I would get the original number that I started with, and that's our process. Okay. We also have, you'll see occasionally isolating a variable. Basically, that's the same as solving an equation. We want to get the variable x by itself isolated on one side. So that solving an equation and isolating a variable, just different phrases for the same thing. Okay, now getting on to the scale analogy. I went through this on the last lesson, so here's just a refresher. So we consider an equation like a scale. This old-fashioned scale has a left tray and a right tray. You put objects or weights on both sides until the scale is balanced, and then you know that the left tray is the same weight as the right tray. So if we were to look at an equation like a scale, I could, for example, I could take the equation 3x plus 1 equals 16, and I could take the left side of the equation, 3x plus 1, I could put that on the left tray, and on the right side I just have 16, so that would go on the right tray. And since there's an equal sign in between them, that tells you that those two trays or the two sides are equal or balanced. Okay, so when I start off, the trays are balanced. The equation is equal. Okay, now what we have to do our goal is to get x all by itself on this tray, and the way we're going to do that is through opposite operations to undo what's being done. Okay, so we're not going to be, if, for example, if I just subtracted 16 from this side but did nothing to this side, well, all of a sudden this tray has nothing. So the tray goes up in the air, this goes down. That means the scale's unbalanced. It also means the equation is no longer equal. So if I wanted to, say, for example, subtract 1 from this side, I would also have to subtract 1 from this side. We have to do the same math operations on both sides. We could add, subtract, multiply, divide, but as long as we're doing the same thing, the equation and the scale will be remaining balanced or equal. Okay, so in the previous lesson we looked at 1- and 2-step equations. We're going to continue on with this approach when we're solving more complicated. So this kind of first two things basically repeat what I was just talking about on this concepts. For multi-step equations, on the next page I'll go through a 6-step process that will work for all equations. Okay, I'll have an example there. Hopefully it'll be a good guide for you to use for any equation that you want to solve. Okay, now you'll see when we look at this full page document, it may look overwhelming. In reality, you probably won't have to do all 6 steps very often. Most of the time you'll be doing 1, 2, or 3 steps. Okay, but the 6 steps will take care of the most complicated looking equations that you could be given. Okay, and again, just like we talked about on the last lesson, once you get your solution, the value of x that makes the equation true, once you get that value, you can check if it's correct by plugging it back in to the equation and seeing if the two sides are still equal. Okay. So on this next page is the 6-step process, the guide for solving equations. So I've kind of numbered all the 6 steps down here. So they're in a predefined order, and you need to follow the steps in that specific order. You can't be jumping around doing step 4 and then step 2. You have to go through. Now, sometimes you'll get to a step and you'll look at the equation and you'll realize, oh, I don't have to do that because, for example, if there's no brackets in an equation, I don't have to do step 2. Okay. I've got 7 down here. 7 isn't really a step. It's just basically saying that once you get to the end, you'll have the solution to the equation. Okay, so I could probably remove that so that when we talk about a 6-step process, those are the 6 steps. Okay, so for the example to follow through on how this works, I picked an equation that actually involves all 6 steps. Okay, and when you first look at this and compare it to the questions we were doing in the previous lesson, this looks kind of overwhelming. One thing that pops out right away is I've got x's more than once, which we never saw in the first lesson. We've got a couple of fractions here. It's quite complex looking. Okay, so the very first thing we always do is take care of the fractions. In other words, get rid of them so that we just have integer terms or integer values of numbers, no more divides or division bars left over. So how can you tell if you need to do this step? Well, if you see anything that has a fraction in it, a division bar or a number by itself, you have to do this. Okay, so I'm going to give each of these steps a one-word description so that when we do the examples on the next page, we can just refer to those step names. Okay, so this step is all about fractions, so I'm going to call this fractions. Okay, so now you could have a very simple, a simpler looking question where you just have one fraction. Say, for example, I just had x plus 5 over 3 equals 1. I didn't have this second one. If you only have one fraction, it's very simple. If I want to get rid of a 3 on the bottom of one fraction, basically that 3 on the bottom means you're dividing by 3. So just like the 1 and 2 step equations, we would just multiply everything by 3. But it gets more complicated when there's more than one fraction. For example, I have a 3 and a 7. If I multiplied everything by 3, it would do a nice job getting rid of this fraction, but it wouldn't help with this fraction. If I multiplied everything with a 7, it would get rid of this fraction, but it wouldn't get rid of this fraction. So we have to take both in this case, or all of the denominators. We have to find the lowest common multiple. That's what the LCM stands for. Once we find the lowest common multiple of all those denominator numbers, we're going to multiply with that number. So how do you find that? So in this case, we have a 3 and a 7. So I'm going to create a list of all the multiples of 3 and then all the multiples of 7. So I just make my list. And you don't really know when to stop. You just kind of go as far as you think you should. And you may need to go farther, because what we're looking for is we need to find the same number in both of these lists. Okay. If there's more than one number in both lists, we take the smallest, the lowest. So we have a 7 multiple here, 14, 21, and you can see, well, I've got the only number that's in both lists is the 21. So that's the lowest common multiple. So lowest common multiple is 21. So we multiply both sides, just like when we think about the scale approach. If I want to get rid of, if I want to multiply one term by a number, that means I have to multiply all the terms, or both the sides. So you can see, here's where I multiply everything by 21. You can see I've got a 21 there, 21 there, and a 21 there. That shows you I've multiplied the original equation terms all by 21. Now, the 21 will always go, in the case of where I have a fraction-like expression, we just multiply the numerator, the top, with 21. Okay, we don't touch the denominator at all. And then if I have an integer, we just multiply that, and it just turns into another integer. Okay, now it's a very easy thing to forget about multiplying the 1 here with a 21, because you're so focused on fixing these two fractions. You're all kind of thinking, well, I don't really need to pay any attention to this because there's no problem with it. But if you ignored that and didn't multiply it by 21, you're basically violating our whole idea of multiplying both sides by the same thing. Okay, so in this case, we'd be multiplying 2 terms with 21 and maybe forgetting that one. So you have to be very complete. Everything has to be multiplied by the same thing. Okay, now you might be tempted at this stage just to start multiplying across the brackets, and it will work, but it's a lot easier with another approach. So that other approach will be looking at the number you just multiplied, okay, and the number that's on the bottom, and just looking at this will actually get reduced to an integer because we picked the 21 for that reason. So 21 divided by 3 is just a 7, so I can replace that whole 21 over 3 with a 7. And then the x plus 5 is still there. I can do the same thing with this term when I'm multiplying with 21 and dividing by 7. If I think about both of those operations together, 21 divided by 7 is 3, and multiplying with 3x minus 1, and then we have our 21 times 1 is 21. Now, one important thing, if you noticed, when I multiplied these two fraction terms with 21, I had to put brackets around the expression if there's more than one term up there, because if I left the brackets off here, I would only be multiplying the x with a 21. If I left the brackets off, it would be wrong, because I'm not multiplying the whole expression x plus 5 by 21. So you can see I've got brackets around both of these binomial expressions. Okay, and so when we get to the bottom here, you can see that it took a bit of work, but we changed our equation from something that had some fairly complex looking fractions into no fractions. Okay, so that tells you we're at the end of the first step because there's no more fractions left. Okay, and definitely this is the most difficult step of all 6. So if you maybe make a few mistakes, don't get discouraged. It takes a bit of practice to become good at this. But just remember some of the things I've been talking about here. The brackets, how to find the lowest common multiple, and the fact that you have to multiply every term with that lowest common multiple, and that number only multiplies with the tops of any fraction expressions. Okay, so the next step in our list is eliminate all brackets. So if your equation didn't have any brackets, you can just skip this step. There's no need to do anything here. You can just go to the next one. So if I had an equation, for example, all my equations in lesson 1 didn't, well, not all of them, a lot of my equations didn't have any fractions, didn't have any brackets. So in that case, we just jump down to the next and see if we have to do that. Okay, so a lot of times you'll just be checking if you need to do something in a step, and a lot of times you don't. So for the brackets, obviously a good name for that would be brackets, because here we're getting rid of the fractions, here we're getting rid of the brackets. So how do we get rid of brackets? Well, we multiply with the term outside the brackets with the terms inside the brackets. Okay, this is something we've done before. So 7 times x is 7x, 7 times 5 is 35, positive 35, 3 times 3x is 9x, 3 times negative 1 is negative 3, and don't forget about the plus 21. So we're not going to do much more than this. We're just going to leave our equation, just multiply through the brackets, and we're done. Okay, you notice, you're done because the brackets are gone. Okay, and then the next step is combining like terms, which you could just call that simplifying. So I'll call this step simplify. So simplify, you might think I have to start adding things to both sides or subtracting. Definitely you don't do that here. So if I have, what I'm looking for is I look at the left side by itself and I say, do I have more than one variable term? If so, I can combine them together. I can add them together. Do I have more than one constant term? If so, I can combine them together. So when I look at the left side here, I see a variable term and a constant term. I can't combine those. I can't combine those into a single term. So there's no simplifying required here. When I go to the right side, I've only got one variable term, 9x, but I've actually got 2 constant terms. So I've got a minus 3 and a plus 21. I can combine those 2 in this step. That's all I'm doing in this step, is combining like terms on each of the sides. So negative 3 plus 21 is plus 18, and we're done. Okay, so at this stage, the most complicated equation you could have at this point would look something like this, where you've got a variable term on both sides and a constant term on both sides. Okay, so we're getting much improved from what we started off with. You can see how the equation is getting more and more simplified. Okay, then the next step. Okay, now just remember, when we get to the end of our step-by-step equation solving, we want to end up with something that looks like, for example, x equals 10. Okay, so we want x equals, and then whatever the value of x is. That's our goal whenever we solve an equation. So if you think about, where do I want my variable terms? Where do I want my constant terms? Well, if I want it to end up like this, I want the variable terms on the left side, and I want my constant terms or my numbers on the right side. So when I look at these, I've got, sorry, down here. When I look at that equation, I've got variable terms on both. Now I only want variables on the left side. So this step, all it does is look at the right side and get rid of any variable terms. So I see a variable term 9x, I don't want it there. How do I get rid of that? I subtract 9x. And when I subtract 9x from the right side, I also have to do it to the left side. So you can see I've got my minus 9x on both sides. And then I'm going to simplify, combine the x's on both. 7x minus 9x is negative 2x. So that's simplified. And of course, this needs to cancel out. That's why we subtracted 9x. So you end up with 0, 0x or 0. So all that's really left is the constant 18. Okay, so I would call this I'll call it variable term. I know I wanted to keep it to one word, but this is where we get rid of the variable term we don't want, possibly. And the next step is similar. Just like we don't want any variable terms on the right, we don't want any constant terms on the left. So here's where I look at the left side only, and if I see any constant terms, I get rid of it. So in this case, I've got a plus 35 that I don't want. How do I get rid of adding 35 or plus 35? I subtract 35. So that's what we've done there and there. And then we just combine the constants. These two will cancel out. So I end up with negative 2x, and 18 minus 35 is negative 17. Okay, and so we'll call this the constant term step. Okay, and then we end up with we'll always have just a variable term equals a constant term. And hopefully at this point it's just x equals a number, but a lot of times it's not. It's a multiple of x equals a number. So basically whatever's being multiplied with x, we want to undo that by dividing by that same number both sides. So that's what this last step is. It's just a final division or divide. So whatever I'm multiplying the coefficient of the variable term, negative 2, we divide both sides by negative 2, and those will cancel out. We just get x. And this simplifies to 17 over 2. In this case, 17 over 2 does make a nice exact decimal value, 8.5, so either of these two would be acceptable. Okay, and by the time you get down to here, you've always got your solution. So whenever you end up with x equals, you're done. You've got the solution, you've isolated x on one side. Okay, so I know that seems a little complicated, but remember I picked this equation on purpose because I knew it would have all 6 steps to it. Okay, so I'm going to practice a few of these. So on the next page I've got 6 examples. I've got 2 where we just have variables on both sides, so just want to give you some practice with that. Then I've got some brackets to get rid of, and then I've got some combinations of things where we'll actually go through the 6 steps. We'll go through the 6 steps here as well, but you're actually going to see that it doesn't involve quite as many. Okay, so if we start off with example 1, we've got, let me just put this over here. So what I'll do is I'll just put my document, the previous page. You can see the keywords along here. Hopefully they remind you of what we need to check for. If you're not quite sure, you just sneak a peek over here to remind yourself what are we doing. Okay, so these questions here, like I've already said, these ones actually have more than one constant term or variable term on each side. So first example is 2x plus 5 is equal to x plus 2. Okay, so if I'm going through my steps, first thing I look for is fractions. Oops, let me move this down. So does this have any fractions? No, it doesn't. Does it have any brackets? No, it doesn't. Do I need to simplify? Remember, if I have more than one constant or variable term on either side, and I don't, so I've basically gone through the first 3 steps with nothing to do. Okay, and now I'm going to get down to this, the variable term. Do I have a variable term on the right side? Yes, I do. So we're going to get rid of that. So on the left side here, I'm just going to put in brackets what I'm actually doing on that step. So I've got 2x plus 5 minus x equals x plus 12 minus x. So remember, we have to do that. Any operation we do when we're solving equations, we have to do to both sides, which I've done. Now we can combine the x terms. You notice I now have 2 x terms on both sides. So 2x minus x, that's just x. And then I have my plus 5. And here I've got x minus x. They cancel each other out. And I'm just left with 12. Okay, and you can see at this point it looks very similar to questions we did in lesson 1. This is a very straightforward one-step equation. But if I used my step-by-step guide, if I continue down, so I just did the variable term, I had to subtract x. Do I have constant terms on the left side? Yes, I do. I've got a plus 5. What's the opposite of adding 5? Subtracting 5. So I'm going to do that to both sides. So that's just x. X plus 5 minus 5 is equal to 12 minus 5. So I did my minus 5s on both sides. Now when I simplify this, the plus and minus 5 cancel. And 12 minus 5 is 7. And you notice normally I would check to see if I have to divide, but in this case I don't have a multiplier with the x. I don't have a coefficient. Well, I have a coefficient of 1, but if I just have x by itself, I'm done. So if you think about it, in the 6-step approach, I only had to do 2 steps. I had to remove the variable term from the right side. I had to move the constant term from the left side, and I was done. So this was really a 2-step equation, but a little different than the 2-step equations we did in lesson 1. So we'll do the same thing here. You'll see this one's quite similar to the first example. I've got a variable term on each side. I've got a constant term on each side. So I can skip through the first 3 steps just like before. No fractions, no brackets, no simplifying needed. So my first thing I would do is to get rid of the variable term on the right. So I'm going to subtract 3x from both sides. So x minus 1 minus 3x is equal to 3x minus 7 minus 3x. Okay, and now when we combine all the x terms, the variable terms, I have x minus 3x, so that's minus 2x, and the minus 1 that's already there. 3x minus 3x cancels out, and we're just left with negative 7 as our only term. So that would have been our step 4, getting rid of the variable term. Now we get rid of the constant term on the left side. So how do we get rid of minus 1 here? Well, we add 1 to both sides. So negative 2x minus 1 plus 1 is equal to negative 7 plus 1. And simplify, these two cancel. So you get negative 2x equals negative 7 plus 1 is negative 6. Okay, now in this case we're not done because I've got a negative 2 that I'm multiplying with the x. Here I just had x. So I actually do have to do step 6 here, where I divide by the coefficient. So here I divide by negative 2. So negative 2x divided by negative 2 is equal to negative 6 divided by negative 2. Lots of negatives that cancel out, and I end up with x equals 3. Okay, so that's examples where we have variables on both sides, variable terms on both sides. You can see it's just a matter of getting rid of the variable term on the right side. You can't have more than one of the variables floating around. You have to combine them in some way, and that's what we did. Okay, now these two, example 2 is all just practicing work with brackets. So the first question here, 3 times x plus 2 is equal to 12. So what we're going to do here is, if you go down the first step in the 6 steps is fractions, no fractions here. Step 2, there's brackets. So we actually are going to get rid of the brackets as our first real step that we're doing. So we get 3 times x is 3x, and then 3 times positive 2. Okay, so we got rid of the brackets. Then we look to see if we can simplify. Do I have terms that I can combine on each side? No, I don't. So then I look for, do I have any variable terms on the right side? No, I don't. Nothing to do on that step. Do I have any constant terms on the left side? Yes, I do. And so that plus 6 I want to get rid of, and the opposite of adding 6 is subtracting 6. I have to do that to both sides. Okay, and of course those two will always cancel because that's where we're doing it. So we end up with a 3x equals 12 minus 6 is 6. Okay, and then the last step would be, do we need to divide? Well, yes we do, because we have a coefficient, we have a multiplier with the x. So we divide both sides by 3. So 3x over 3 is equal to 6 over 3. 3's cancel. 6 over 3 is 2. Okay. Same idea over here. This one's a little more complicated than this because we've got 2 sets of brackets, one on each side, and you can see we've also got 2 x's. Okay, but no big deal. We know how to deal with those. But the first thing we do, because there's no fractions, is multiply across the brackets to get rid of the brackets. So we have 5x plus 10 equals 4x minus 4. Okay, can we simplify? No need to, because we've only got constant term and variable term on each side. But the next step would say, do we have any variable terms on the right? Yes, we do. I want to get rid of the 4x. So how do I get rid of the 4x? I subtract it. Okay, so I'm going to subtract 4x on both sides. Equals 4x minus 4x. So here, I combine the 5x and the minus 4x. 5 minus 4 is 1. So I could either write 1x or just x. I'll just do x. X plus 10 is equal to 4x minus 4x cancel, and I'm just left with negative 4. So we got rid of the variable term on the right. Now we see if we need to get rid of a constant term on the left, and we do. So the opposite of adding 10 is subtracting 10. That's what we'll do. So subtract 10 from both sides, and we get x equals negative 14. And again, just like in 2a, we didn't have to do the divide step, the step number 6, because we ended up after step 5 with just x equals a number. So that tells us we're done. Okay, the last 2 questions, you can see these ones are a little more similar to the example we did when we talked about the 6-step process. So this will give us a chance to try things out. Okay, so you can see definitely both of these we're going to do the fraction steps. Okay, so first thing we have to figure out is what's the lowest common multiple. So again, in order to get that, so I didn't really explain what does the lowest common multiple actually mean. It's the smallest number that you can divide by both of these numbers. So what's the smallest number? I can divide by 2, and I can also divide by 3. You can come up with that on your own, but this is the method that if you're not so great at coming up with the lowest common multiple, this always works. So the multiples of 2, 2, 4, 6, 8, multiples of 3, 3, 6, and I can see already I've got a 6 in both. So that's the lowest common multiple. So I can put that up here. LCM equals 6. And once we've got that lowest common multiple, it means I got to multiply all the terms by 6. So if I look at the first term, x plus 1 over 2, I'm going to multiply that by 6. And remember, if I'm multiplying by 6, it's only the top that gets multiplied by 6. You can actually think of 6 as a fraction, 6 over 1. So you're really multiplying this top by 6, the bottom by 1. Multiplying by 1 doesn't change anything. So I'm going to put a 6 in front of here on the top. But remember, I'm multiplying the whole thing by 6. So I have to put brackets around x plus 1. Okay, so I've multiplied that term by 6. Now I have to multiply the 3 by 6. So 6 times 3, even though it's not a fraction, still have to multiply it by 6. And then we've got our right side. So I'm going to multiply the 2x by 6. And don't forget, you got to keep bringing these denominators along. They don't disappear yet. And then I multiply the 5 by 6. So subtract 6 times 5. So you can always check and go back, make sure, did I multiply everything by 6? Yes, 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 and yes. So I've kept the equation balanced, but it's now put me in a position now where I can eliminate the numbers on the bottom. So let's go through each of those and simplify this. So again, first of all, I figure out what's the result of multiplying by 6 and dividing by 2. So 6 divided by 2 is 3. So I'm multiplying, overall, I'm multiplying this by 3. So 3 times x plus 1. And I can multiply this out. So that's 18. Now this one here is a 2. 6 divided by 3 is 2. So I have a 2 overall from what's inside the bubble there. So 2 times what's ever on the top. So I might as well multiply that out. It's not that hard. 2 times 2x is 4x. Okay, so you can see I got rid of the fraction there as well. And then the last thing to do is multiply 6 and 5. So I get minus 30. And you can see I've got rid of all the fractions. So the next step would be brackets. Only one set of brackets. So that's what I'll do here. Multiply the 3 with the x and the 1. So 3x plus 3 plus 18 is equal to 4x minus 30. Okay, so that's the end of step 2. First got rid of the fractions in step 1, then I got rid of the brackets in step 2, and now we can simplify. And there's one place where we can simplify because I've got a plus 3 and a plus 18 on the left side. So let's combine those two into a plus 21. Nothing changes on the right side because it can't be simplified. Okay, and now we get to the step 4, which says get rid of any variable terms on the right. And you should only have one at this point because you should have combined them if there was more than one. So I'm going to subtract 4x from both sides. So 3x plus 21 minus 4x is equal to 4x minus 30 minus 4x. Okay, and when I combine the x terms on the left side, 3x minus 4x is negative 1x, or just, you could put negative x or negative 1x. I'll put negative 1x and then the plus 21. It's already there. And here, you can see the 4x and minus 4x will cancel. So I just have negative 30. Okay. And then the next step, that was step 4. Step 5 says get rid of any variable terms, get rid of any constant terms on the left. So I have a plus 21 that I don't want. So I'm going to do the opposite, which is subtract 21 from both sides. So I have negative 1x plus 21 minus 21 equals negative 30 minus 21. Okay, kind of running out of room here. Sometimes these can be longer than you think. So here the 21 and minus 21 cancel. Okay, so I'll bring it down here. So I'm left with negative 1x. And here combine the negative 30 and the negative 21 equals negative 51. Okay, It's a little hard to read. It says negative 1x equals negative 51. Now, you might think you're done because that sort of looks like an x by itself, but it has to be positive x by itself. So here, when you see it with a negative 1, it's more obvious. What I have to do is divide by negative 1. Okay, so when I do that, both sides, you end up with x equals, and then negative 51 divided by negative 1 is just 51, positive 51. Okay, so this obviously was the most complicated one so far. We had to get rid of the fractions, get rid of the brackets. We also had to simplify. We had to get rid of the variable term on the right. We also had to get rid of the constant term on the left, and we had to divide. So this one we actually had to do all 6 steps. Okay, so this is as tough as it can get. Okay, let's do the final example. So again, we've got fractions, so we have to do step 1. So I'm focusing in on those 2 denominators, 2 and 5. So I want to get the lowest common multiple of 2 and 5. So if we write out our multiples, you can see pretty quickly this one, it will be 10. 10 is the lowest common multiple of those 2. So that means I have to multiply everything by 10. So when I rewrite this, if I'm just looking at that first term, I'm only multiplying the top by 10. So this one's a little bit different because I already had like a number multiplying with the brackets. So I can just put the 10 in front of that. Now, in order for you to understand that it's not 105, I'm going to put brackets around either one of those or both of them. Okay, I like to do both just to keep it obvious what's going on there. So on the right side, I've got my 4x minus 1 on the top and 5 on the bottom. I want to multiply everything by 10. So I do the same thing here. I put a 10 on the top, put brackets around the 10 and the 4. Okay, and then I've got my plus 1. But again, I want to multiply that by 10 as well. Even though it's a fraction, it has to be multiplied by 10. Okay, so now we're going to clean this up. So what am I looking at? I'm just focusing on these multiplying and dividing integers to come up with a single number from those 3 and those 3. So you could do this in your head or calculator, it's up to you, but 10 times 5 is 50, and then 50 divided by 2 is 25. So that whole bubble gets replaced with a 25, and I've still got my x plus 2. Okay, here I've got 10 times 4, which is 40, divided by 5. 40 divided by 5 is 8. And then I've got my x minus 1 that was already there. And here, 10 times 1 is 10. Okay, so you can see here I've got, when I wrote this, I got rid of the fractions. So now look for brackets. And yes, we have to multiply through the brackets to get rid of them. So I've got 25 times x, 25 times positive 2 plus 50. 8 times x is 8x. 8 times negative 1 is negative 8. And then the plus 10 from before. So got rid of the brackets. And now we see if we can simplify. So hopefully you're getting the hang of what that means. If I have more than one variable term or constant term on each side, I combine them. And this left side, I can't do anything. But the right side, I can put together the negative 8 and plus 10. So 25x plus 50 is equal to 8x, and that would be plus 2. Okay, so that would be step 3, simplifying. And now step 4, which says get rid of the variable term on the right. So I want to get rid of 8x, so I'm going to subtract 8x from both sides. 25x plus 50 minus 8x equals 8x plus 2 minus 8x. So you can see, make sure you're doing the same thing to both sides. So when I combine these x's, 25 minus 8x, 25x minus 8x is 17x plus 50. and these two x's cancel, and I have a positive 2 left over. Okay, so that was step 4. Step 5 says get rid of any constant terms on the left. So that's the plus 50, so we subtract 50 from both sides. Okay, when we simplify this, we get 17x is equal to 2 minus 50 is negative 48. Okay, and now last step, we're going to divide everything by the coefficient, the multiplier of the x. So that's 17x over 17 is equal to negative 48 over 17. So those x's, those 17's cancel, and we end up with x equals. Now, we can't do anything to reduce 48 over 17 or negative 48, so we just leave it as it is. So you don't always get a nice integer answer. Sometimes you do get, a nasty looking fraction. I think this was the first fraction we had on this example. Okay, so hopefully these 6 examples showed you some more complicated equations to solve compared to the first lesson. And I'm also hoping that this step-by-step guide, let me zoom out to show you the whole thing. Okay, that's it's all 6 steps right there. So if you just remember the key points of each of the steps: fractions, brackets, simplify, variable term, constant term, divide. You're just checking, do I need to do this for this equation? And like we did have a couple of examples where we had to do all 6. We had a couple of examples where we only had to do 2. So it depends. Every equation is a little bit different. But if you follow these steps in the correct order, it's all laid out for you, so you don't have to stress out over, well, what should I do next? Because it can look very complicated sometimes. Okay, so that's it for lesson 2. There are some homework questions to practice this. Like I said in the previous lesson, this skill, solving equations, is one of the most important skills going forward into grade 11 and 12. So the more practice you get, the better you are at solving equations, the better you'll do next year as well. Because in grade 11, you start solving even more complicated equations. So it's good to have a good basis in this. Okay, in the next lesson, I believe it'll be the final lesson in this unit, we are looking at creating equations from words. And then once we've created the equation, we can solve it. So that's also an important skill, but we have to have this background in from lesson 1 and 2 first. Okay, so have yourselves a great day, and we'll see you on the next lesson.